Hi everyone, I am Prachi Agarwal. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week we'll post CodeChef problem explanations, conceptual videos on various programming paradigms and also conduct live problem-solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great! Now that you have subscribed, let's get started. Today we'll be solving the problem yet another crossover episode, which is an October Cook Off problem, and it is an easy problem based on simple mathematics. And so the agenda for today is that first we will try to understand the problem statement. Then as usual, we'll understand the concept by which we can solve this problem mathematically. And then we will discuss the pseudocode and also do a quick walkthrough of the code, which is in Python. So let's get started. So before we rush to the problem statement, I have some great news with you. Unacademy, in association with CodeChef, has come up with live competitive programming classes. Yes, you heard me right. So these classes will be taken by the top coding experts from around the world, ICPC finalists, women tech makers, and whatnot. So if you are interested in really learning competitive programming and about data structures and algorithms, then you must join this course. So it is only $999 per month, and you can get an instant 10% discount by using my referral code, which is given in the description box below. It is Prachi16, so please do subscribe for 1 month and get your competitive programming going. So guys, this is our problem statement. Let us understand this. So in the problem statement, you are given an integer d, and you have to find an integer sequence, that is a1, a2 up to an. That is, you have to find a sequence of length n, and the elements of the sequence are a1, a2 up to an, such that the following conditions are satisfied. Now, the first condition is that your length of the sequence should not exceed 10 to the power 5. The second condition is that each element must also not exceed 10 to the power 5. So, each element of your sequence a1, a2, an must lie in the range of 1 to 10 to the power 5, including 1 and 10 to the power 5 itself also. And now the third condition, so this is an expression, and this expression will evaluate to d that was given to us. Like here, the first line you can see that we are given an integer d. So this expression will evaluate to d. Now in this expression you can see that we are given two summations. The first summation runs from I equals to 1 to n, and the second summation runs from j equals to I to n. So this seems like a nested for loop. We can have two for loops for these summations. Also, one more thing to notice is, in the first part of the expression and the second part of the expression, we have the same summations, only the minimum and GCD differs, and we are supposed to find the minimum for the same group as well as the GCD also for the same group of elements. So this statement can also imply that we can take these two summations in common and then write this expression minimum minus GCD together like this. So this expression and this expression mean the same thing. So this is our problem, and now we are supposed to understand what the third condition or the third expression it means. So you can see here that we are given two summations. The first summation is from I equals to 1 to n, which can also mean that we are running a for loop from I equals to 1 up to n, right? Now the second summation, so the second summation is within the first summation, so it means that it is a nested loop, and this second summation is the inner for loop. So this summation is running from j equals to I to n, so we can say that the inner for loop will run from j equals to I up to n. Now after both these for loops, we are supposed to find the minimum and the GCD of a particular group of numbers. Let us see what these group of numbers are. So they are from a of I up to aj. That means if your I is equals to 1 and j is equals to 3, then the elements for which we are supposed to calculate the minimum and GCD will be A1, A2 and A3. So this is how it goes. So for finding this sequence out, we will also have to again run one more for loop. And for that for loop, we will take the variable as k and it is running from I to j, right? So we will make k equals to I and run it up to j. So this will be the third for loop for just finding out this sequence. And once we have this sequence, so what we'll do, we have to find the minimum and GCD of this subsequence. So a of I up to aj, we are calculating the minimum of this sequence and also the GCD of the same sequence. And once we have calculated the minimum and GCD of the sequence, then what are we supposed to do? We are supposed to accumulate this minimum minus GCD into our answer, because here you can see that we have these summations here, right? So summations means that we have to keep adding whatever minimum minus GCD we are calculating each time in the entire process. This is how this expression is running. And this expression is running for which sequence? This expression is running for the sequence that we are supposed to find, A1 up to AN. So considering that this sequence already exists in the problem, we are supposed to find it. But if for a moment we try to understand that this the sequence is already existing, and let's take n equals to 3, means this is a sequence of length 3. So the sequence will be A1, A2 and A3, right? This will be our sequence. So for this sequence, what will be our flow of calculating in this expression? So I have already made this table, and this table is made in accordance to this pseudocode that we have discussed here. Okay. So we have 3 elements in our sequence. So I will run from 1 to n, that is the outer for loop. So you can see that I is running 3 times, 1, 2 and 3. Now for each I, again j will run from I to n. So that is what is precisely happening here. For 1, j is running from for 1, 2 and 3. For I equals to 2, j is running from 2 to 3. And for I equals to 3, j runs for only 3. And now let's talk about the expression that we are supposed to calculate, that is minimum minus GCD. So minimum of a particular group and the GCD of the same particular group of elements. So this group of elements, they are from AI up to AJ. So here I is also 1, j is also 1. So we are calculating the minimum and GCD of only A1. Now if you look at this third one, then you can see that I is 1 and j is 3. So that means AI up to AJ, that means A1 up to A3. So we are calculating the minimum and GCD of A1, A2 and A3. So if you carefully observe this table, what you can see is that each time we have to calculate the minimum minus GCD expression for all the subsequences of our sequence. If your sequence is A1, A2, A3, then all the subsequences of your sequence will be A1, A2, A3. This will be individually A1, A2, A3. Then it will be A1, A2, then A1, A2, A3, again A2, A3. So these are what are we exactly doing? We are calculating for each of the subsequences, right? So now in the further problem, we are just going to talk about these subsequences, because our problem reduces down to calculating this expression for all the subsequences of our sequence. Now we are supposed to find the sequence, right? A1, A2 up to AN. Let's talk about some subsequences and what answer they will contribute to our summation. So if your subsequence contains just a single element, that means suppose that your subsequence is just 4. So what will be the minimum of this subsequence? The minimum of the subsequence will definitely be 4. That means the element itself, and the GCD will also be the element itself only. So the answer that it will contribute to our summation will be 0, because we are supposed to do minimum minus GCD, right? So both minimum and GCD are same. So that is why the answer contributed to the summation will be 0. Now the second thing, that if our subsequence consists of 2 consecutive elements, like here I have taken p comma p plus 1. These are 2 consecutive elements. So let's take p equals to 4, then p plus 1 will be 5. Now what will be the minimum of 2 consecutive elements? It will definitely be p for p or p plus 1. And what will be the GCD of 2 consecutive elements? So the GCD of 2 consecutive elements will always be 1. So do you agree with me that the GCD of 2 consecutive elements will always be 1? Why? Because this one is even and this one is odd element. So according to the Euclidean GCD formula, we can say that the GCD will always be 1 for these 2 elements. So the answer contributed by such a scenario will always be p minus 1. P minus 1 will be contributed to the summation. Okay. Now what do we want? We want that in our final answer or summation, we should be getting D. Because if you remember that expression, so after we have calculated the minimum minus GCD of all the subsequences of our sequence, we will get our answer as D. So can we not make such a sequence that only one subsequence will contribute our answer as D and rest all other subsequences will contribute their answer as 0. So let's see. Here we are getting the answer as p minus 1. Let us make it D. Let us equate it to D. So then what will be p now? If we equate this answer to D, then p will become D plus 1. So likewise, p plus 1 will become D plus 2. So now, if we take our sequence for any given D, if we take our sequence to be D plus 2 and D plus 1, then sure shot we can get our answer as D. How? Because all the possible subsequences of D plus 2 comma D plus 1 will be, what will be all the possible subsequences? So one possible subsequence is D plus 2, the other possible subsequence is D plus 1, and the third possible subsequence is D plus 2 comma D plus 1. These are the only 3 that can exist. So we have already established that for a single element, minimum minus GCD will contribute the answer as 0. So for both of these subsequences, we will get our answer as 0. And for this one, for the last one, we will get our answer as D. So this we have established from the second point, that if you have 2 consecutive elements, then you can, if p and p plus 1, then the answer contributed will be p minus 1. And we made it D. So according to that only, we have derived that we can take our expression as, or we can take our sequence as D plus 2 comma D plus 1. So all in all, we will get our answer as D. So let us take an example. Here D is equals to 5, and we already established that for any D, we can always take our expression as D plus 2 comma D plus 1, and this will give us our answer. Now So this expression d plus 2 comma d plus 1, if d is 5, then this expression will be 7 comma 6. And this one will be a1, this one will be a2. So we can always say that for any d, we can always suffice our expression by taking just 2 elements in our sequence. And if you remember, what was the expression that was given to us? It was I equals to 1 to n, then summation of j equals to I to n, and then we were supposed to calculate the minimum of ai up to aj and minus gcd of ai up to aj, and this was supposed to be d, right? Now, according to this only, I have made this table here according to this expression that we were supposed to calculate. And also, you know that we were just supposed to calculate minimum minus GCD for each of the subsequences. So, and both mean the same thing. So, here minimum of A1 minus A1, so A1 is 7, and you already know for a single element, your minimum and GCD will be same. So, here the answer contributed will be 0. Then these are 2 elements A1, A2. So this also we have discussed that for 2 consecutive elements, what will be our contribution? So for d plus 2 comma d plus 1, the contribution is d. So d is 5. So here our contribution will be 5. And for again, this is a single element. So again, the contribution will be 0. And after adding all these 0 plus 5 plus 0, we have got our answer as 5, which is equivalent to d. So we can say that what sequence are we supposed to take each time? For any d, we can take this sequence d plus 2 comma d plus 1. This will be our sequence, and the length of the sequence will be 2 always. But is this true for all the cases? No. We have one trick here, that our d can be, the upper range of d can be up to 10 to the power 9. And for the test cases, it's fine because the upper range is only 10, so it's not very large. But for d, we are given a very large range, that is 10 to the power 9. But in our problem statement, the sequence must not exceed 10 to the power 5. Any element of the sequence must not be greater than 10 to the power 5. And what are we supposed to print? So we are supposed to print 2 lines. In the first line, we will print the length of the sequence, single integer n, and in the second line, we will print the sequence itself. Okay. So now let us focus on this part, that each of the elements in the sequence must be 10 to the power 5. So, if you see here, then first let's discuss that up to what range this solution will work. So, maximum any element in the sequence can be 10 to the power 5. That means d plus 2 can be maximum 10 to the power 5. Beyond that, we cannot take. This was a constraint in our problem. So, d can be maximum 10 to the power 5 minus 2. So, this solution here that we have discussed will only work if our d is 10 to the power 5 minus 2. But what about if your d is greater than 10 to the power 5 minus 2? Let's see how we will find out our solution then. So now let's bring in one more observation regarding our subsequence. If our subsequence contains 1 as the element, so anything, our subsequence can be anything, a1, a2, and in between 1 or anywhere 1, and then so on. This is our subsequence. Then in that case also, the answer contributed will always be 0. So because the minimum of any subsequence which contains 1 will always be 1, and the GCD of that subsequence which contains 1 will also always be 1. irrespective of whatever other elements are in the subsequence. So that's why the answer that it will contribute to the summation will always be 0. And the second fact you already know, that for any subsequence, like we had d plus 2, d plus 1. So here I have taken p plus 2 and p plus 1. For that, the answer contributed to the summation will be p. So if we want for a sequence to give the total answer as p, then we can also take our sequence to be p plus 2, p plus 1 and 1, and the answer will remain p. Because why? Because we already know that for all the subsequence with a single element, like single element p plus 2, p plus 1 or 1, the answer contributed will be 0. Then second possibility is that the first possibility was a single element. So for a single element, answer is 0. Then the second possibility is that there are two elements, right? For two elements subsequence, so there are just two possibilities, p plus 2 comma p plus 1 and p plus 1 comma 1. So you know that if your subsequence is p plus 2 comma p plus 1, then you will get the answer as p. And if your subsequence contains 1 in it, p plus 1 comma 1, then definitely the answer will be 0. And the third possibility will be 3 elements. So if there are 3 elements, then definitely 1 will always be a part of those 3 elements of the subsequence. So again the answer will be 0. So we can say that just like p plus 2 comma p plus 1 as the sequence was contributing p to the answer, so likewise p plus 2 comma p plus 1 comma 1 will also contribute p to the answer, means the total answer. So what we can do is that we can take this segment p plus 2 comma p plus 1 comma 1 multiple times. What will be the advantage of taking this multiple times? Because now we can always take this p plus 2 as 10 to the power 5, and each time what it will contribute us, it will contribute p to the answer. So each time we can keep on contributing p equals to 10 to the power 5 minus 2 to our answer if your d is greater than 10 to the power 5 minus 2. So why are we discussing this part of the problem is because d can also be greater than 10 to the power 5 minus 2. So up till 10 to the power 5 minus 2, there was no problem. We could just have taken our sequence as d plus 2 comma d plus 1. But now we need to change our sequence a little bit, and what changes have to be done? So the only change that has to be done in our sequence is that it has to be a repetition of these particular segments p plus 2, p plus 1 and 1. And how this will keep on contributing 10 to the power 5 minus 2. So let us check that also, that for any, this we already know that for any subsequence which contains 1, the answer contributed will always be 0. So no matter how large your subsequence is, but the answer will always be 0 for that. Then second thing is that for any one digit sequence, that is if the length of your subsequence is just 1, then again the answer that it will contribute to the summation will be 0, because minimum and GCT both will be the element itself. So answer will be 0. Then if there are 2-digit sequence which does not contain 1, so what will be the 2-digit sequences which does not contain 1? It will be just p plus 2 comma p plus 1, because you can see here that the subsequences of length 2 which does not contain 1 will only be these. So here the answer contributed will be p, and if we take p plus 2 as 10 to the power 5, then each time we will be able to contribute 10 to the power 5 minus 2 in our summation. Now the and then this here the rest of the 2-digit subsequences will be those which contain 1 in them. So for that again the answer contributed will be 0. Now the fourth observation is that if the subsequence is of length greater than equals to 3, then again the answer will definitely be 0. Why? Because if you see properly in our sequence, in our main sequence, every third element is 1. So no matter which 3 element or greater than 3 element subsequence we pick up, it will always be that in our subsequence there will be 1 present. And if 1 is present in our subsequence, then again the answer contributed to the summation will be 0. So we can sure shot say that each time for each of this segment, for each segment p plus 2, comma p plus 1, comma 1, the answer contributed will be 10 to the power 5 minus 2. Now, the question is how many times we need to put this segment into our sequence. So, the number of times that we need to put this segment into our sequence is whatever your d is divided by 10 to the power 5 minus 2. So these are the number of times that you will keep on putting this segment in your main sequence. And each time you put this segment into your sequence, you will also do d equals to d minus 10 to the power 5 minus 2, because each time it is going to contribute this into our summation. So we will reduce this from d, and then at last we will also have some remainder, right? D divided by 10 to the power 5 minus 2, it cannot always be that d is divisible by this number. It cannot always be so there will be some remainder. So when we get that remainder r, then what we can do, simply at last we can just put this r plus 2 comma r plus 1 into our sequence, because r plus 2 comma r plus 1 will again contribute r into our answer, and that is what we precisely need. So this way we can say that for any d, for any given integer d which is greater than 10 to the power 5 minus 2, we can ensure our answer by creating such a kind of sequence. When d is greater than 10 to the power 5 minus 2, then this will be our sequence, that is repeated segments of p plus 2, p plus 1, comma 1, again p plus 2, p plus 1, comma 1, up to so on until we get a remainder, and for the remainder r plus 2 comma r plus 1. So let's do a quick let's discuss a quick summary of how we arrived at our solution. So for each segment p plus 2 comma p plus 1 and 1, we already know that it will contribute p to our summation. So for this, the answer we will get is as p. Now second point is that if your d is greater than 10 to the power 5 minus 2, then we cannot directly take this sequence as our answer. If your d is less than or equal to this number 10 to the power 5 minus 2, then this sequence will work perfectly. But if it is greater, then what we can do is that we can take our p as 10 to the power 5 minus 2, which will get contributed each time because of this sequence. So if we just repeat these segments into our sequence, then how many of these segments we will need? We will need b divided by p such segments, because this segment is always contributing p to our answer. Then after we have put d divided by p such segments into our sequence, there will definitely be some remainder that will be left. So because each time we will keep on subtracting p from the d. because d is much greater than 10 to the power 5 minus 2, and each time 10 to the power 5 minus 2 is contributed, it will get subtracted from d. Now what will happen, that when there will be a remainder left, so again this remainder will always be less than 10 to the power 5 minus because we are dividing d from p, which is 10 to the power 5 minus 2, so definitely the remainder has to be less than that. And if your remainder is less than this number, then you can directly just contribute r plus 2 comma r plus 1 to the sequence, because we already know that for any integer, if it is less than 10 to the power 5 minus 2, then we can directly take this sequence as our answer. So if we concatenate 1 at the end, or if we don't concatenate 1 at the end, so that does not make a difference, because both will contribute the same answer, that is r, to our summation. So guys, this is how we are going to do the question. Now let us discuss the pseudocode. So the pseudocode is pretty simple, guys. First, we are supposed to take p equals to 10 to the power 5 minus 2, because that is our upper limit that we can have, because our segments were p plus 2 comma p plus 1 comma 1 and up to so on. So this p plus 2 will be 10 to the power 5 minus 2 plus 2, it will be equals to 10 to the power 5, which the elements cannot exceed in our sequence. So that is why we are taking the highest one that we need for each segment to contribute is 10 to the power 5 minus 2. Now we will run a loop, and this loop has to run till d is not equals to 0. So what have we done here? We are selecting minimum of p comma d. Why so? So we already know that if d is greater than 10 to the power 5 minus 2, then in that case we have to put these segments into our sequence of p plus 2, p plus 1 comma 1. So that is why if your d is greater than this number, then what can be the minimum p that can be contributed each time? So it can be 10 to the power 5 minus 2. That is why we have taken minimum of p comma d. And if your d will be less than this number, then definitely d will be selected as p, and we will just need one single segment of this p plus 2, p plus 1 and 1. And then each time we are just going to add p plus 2, p plus 1 and 1. This entire segment is going to contribute p to our answer. And then at last, we are supposed to subtract p from d. So suppose like I'm sure that this greater possibility must be clear to you up till now. But if suppose your d is a smaller number, that is 7, so here minimum of p comma d, definitely in p now 7 will be stored. Then in the answer we are going to add 7 plus 2, 7 plus 1 and 1. So what will be our sequence that will be formed? 7 plus 2 is 9, 7 plus 1 is 8 and 1. This will be our sequence, and this sequence will contribute p. And what is p? So p is 7, and that is what we require in our answer. So this sequence will contribute d to the answer, that is 7. And then if we will do d equals to d minus p, so d was 7 and p is also 7 now. So 7 minus 7 will be 0, right? So it will come out of the loop. But in case your d was greater than 10 to the power 5 minus 2, then it is not going to come out of the loop, but it will keep on calculating like this only till the time it reaches the remainder. And then the remainder will also be for the remainder also we are going to add this segment only into our sequence and then form our answer. What will be the time complexity of this problem? So the way we have solved our problem, we know that we need to keep d divided by p segments of p plus 2, p plus 1, comma 1. So guys, what will be the time complexity of this problem? So we already know that p plus 2 comma p plus 1 and 1, these segments we are going to include in our sequence d divided by p times. So these many times the loop is definitely going to run, and plus 1. So plus 1 is for the remainder that is required to be added at the end, r plus 2 comma r plus 1. So the total time complexity will be this for our problem. Just a reminder guys, have you considered subscribing to the Unacademy live classes that is specially for competitive programming? If not, then do go for it because it will be great for you. There will be live sessions, doubt solving sessions, practice problems, and you can always, ask your doubts whenever you have them from the top coding experts of the world. So go for it if you want to enhance your competitive programming skills and data structures and algorithms, which is the current industry trend. Then you should definitely go for this course. And it is just rupees 999 per month, and you will also get an instant 10% discount by using my referral code, which is Prachi16. So go for it and keep coding. So guys, let us discuss the code now. On your right, you have the variable description as usual, and the code is just approximately a mirror image of the pseudocode that we just discussed. So it does not really matter whether we discuss the code or not. So still, let's do it. First one is the input. First line is the input for the number of test cases, and then again for each test case we are supposed to input d, an integer that is given to us. Then our code begins from here. So this I already explained in the pseudocode that first of all our p will be 10 to the power 5 minus, and answer is an empty array. So here in Python we have a list. In other languages you can probably take an array list, or you can also take an array, but then you will have to take care of the indexing in an array. So you can also take a stack, whichever one suits you the most. Then one more case that I did not discuss in the pseudocode was that if your d is equals to 0, so the range for d was given as, the lower range was that d can also be 0. So if your d is 0, then the answer will just be 1. So and if your answer is 1 and the minimum of 1 is 1, GCD of 1 is 1, so it will contribute 0 to the summation, and that is what we need. So this we have written separately here, and in the array we will add or append 1. But if your d is greater than 0, then we are going to follow the same thing that we discussed in the pseudocode. That is, first we will see which one is minimum, 10 to the power 5 minus 2, or our d is minimum, that is d is less than or equals to 10 to the power 5 minus 2. Then we will only need to run this loop just once. Otherwise, we will need to run this loop d divided by p number of times. So, and each time the contribution to the summation will be 10 to the power 5 minus 2. So that is why we need to determine this here. And then again we just need to form the segments in our sequence, that is p plus 2 comma p plus 1 and 1. So one by one we are adding that into our sequence, that is answer. And then after adding these we are just subtracting p from the answer, because we know that p has been contributed each time. Then after coming out of this loop, we will directly print the length of the sequence that we have formed. This is our sequence, and we will print the length of the sequence. Then in the second line, we are required to print the entire sequence, space separated sequence. So for that, I have written star answer here. So what in Python this does is that it prints our list into the form of a space separated sequence, because the separator here is a single space. So and end means that the next time that we print something will automatically go on the next line. So this you may or may not put into your code, but I have put it here. So that's it, guys. This is the code. Now, like the video if you enjoyed it, and there are multiple other solutions for this problem too. So do rack your brains to think of some other solution, and if you have it, then please post it in the comment section below so that everyone else can also benefit from that solution. And please subscribe to our channel, and don't forget to hit the bell icon so that you can stay notified of all the upcoming updates.